Hi, in the previous video, I showed you how to build an AI agent using Langgraph and how to make it available as an API from Azure App Service. So this AI agent connects to the GPT 4.1 model from the Azure OpenAI service, and it connects to an MCP server which exposes two tools. Okay, so one of the tools, what it does is given an address, it converts that into geocodes. And the other tool, given if you provide the origin and destination details, it would provide you the travel details. It would also consider the current traffic conditions. Both of these tools leverages the APIs exposed by the Azure Maps services. Okay, and I've also showed you how to configure observability and then see the traces from the Langgraph agent. Okay, so what I've built in that previous video is essentially a stateless agent. What I mean by that is, let me go to Postman and show you. Okay, so the AI agent is running on Azure App Service, and this is the endpoint to interact with the agent. Okay, so I've already configured the authentication and authorization for the Azure App Service. So in order to interact with the agent, you need to generate an OAuth access token and then use it as a bearer token. Okay, so I've already added the scope, the access token endpoints, and the token endpoints and the auth endpoints within the Postman here, and also the scope as well, right? So let me generate an access token, okay, and then let me use this access token and then use it as a bearer token when I call the API. So here is my question. So basically, as you have seen in the previous video, right? So I would like to travel from Dallas Aquarium to San Antonio. Please help me with the details, right? So how long does it take to travel? Let's see what the AI agent comes up with. As you can see, the AI agent responded saying, the estimated travel time by car from Dallas Aquarium to SeaWorld San Antonio is approximately 4 hours and 14 minutes, and the total distance is 285 miles. Okay, let me ask a follow-up question to this AI agent. Okay, I would say, I would ask, what about the return trip? Okay, so the AI agent says, could you please provide a bit more context? Are you referring to a specific trip, route, or travel plan? If you let me know the original destination or the details of your initial trip, I can help you calculate or plan the return trip as well, right? So it looks like the AI agent doesn't remember my previous question, right? So let me also ask another question. What was my previous question, right? So it clearly says you haven't asked any previous questions in this conversation, right? How can you assist you today? So when I said stateless, right? So this is what I mean, right? So the AI agent doesn't remember any of my previous question, right? So it's stateless. It doesn't have any memory, it doesn't know anything about my previous questions, even though I'm interacting with this AI agent more like in a session here, right? So in this video, I'm actually going to show you how to make this AI agent stateful. How to make this API stateful so it remembers my previous questions as well. Okay, let's get started. So let's go to Langgraph docs here. So if you look at Langgraph docs, right? So this talks about memory. So memory is a system that remembers information about previous interactions, right? Looks like this is what we need, right? But there's two types of memories. There is a short-term memory and there is a long-term memory. As you can see from the docs, right? Short-term memory or a thread scope memory tracks the ongoing conversation by maintaining message history within a session. Okay, and then long-term memory stores user-specific or application-level data across sessions and is shared across conversational threads. Right. So in this video, I'm going to focus more on the short-term memory here. Right. So I want to keep track of the conversation agents within that session. Okay. So in Langgraph terminology, there's something called thread. So basically, thread is similar to a session. Okay. Um, let's go into a few more details. Right. So basically, when you so to in order to use this short-term memory feature, right? So from Langgraph, you need to use a checkpointer resource. Okay. So when you compile the graph before you want to use the line graph, right? So you need to pass in a checkpointer resource and then compile the graph. Okay. What it allows us with the line graph is, it would whenever you invoke the graph after you compile the graph with a checkpointer, it saves the graph state at each and every super step. Okay. Let me zoom this in a bit. Okay. So whenever the node is executed, at each and every super step, it creates a checkpoint, which represents the graph state, and then it stores to the checkpointer resource. And the thread is essentially a collection of checkpoints, right? As I said previously, right, thread is more like a session. So all of your interactions with that agent, if you pass in the same thread ID, so all the checkpoints would be tied to that particular thread. Okay, and each checkpoint is a state snapshot object. Okay, I think it would be clear when I actually show you it in the demo. Okay, so for this purpose, right? So I'm going to use the in-memory checkpoint saver. So this is the in-memory saver from the Langgraph SDK. So I'm going to show you in action here. So let's go to VS Code. So I have this agent stateless. I've showed you this in my previous video, right? So um, okay, but then I've built another Python module here using the InMemorySaver class from the Langgraph checkpoint memory. Okay, let's do a comparison between these two files here. So if you look at these two files, right? So the agent state, this module, I've imported the InMemorySaver class from the Langgraph checkpoint memory. Okay, so that's one difference that you notice. I'm using the local MCP server. You know what? Let me start that MCP server here. So my MCP server is running on port 8086. Okay. Um, as you can see, right? So I mean, same as from my previous video, right? So I have this state um, schema defined I'm calling it as an agent state, and then I'm using the messages here to, and then I'm using the add messages reducer to append messages to this messages variable. And then if you look at it, right, so I have the in-memory saver object, instantiated here, and then when I'm compiling this graph, I'm passing the checkpointer resource, which is the in-memory saver object, to this graph. Okay, and then when I'm executing this graph, I created a config here, and then I'm giving the thread ID 1, um, and then I'm using that config when I invoke the graph. So I'm doing the asynchronous streaming here, and then I pass the config file and the config values here. Okay, so this is my first question, same as what you have seen in the Postman. So I would like to travel from Dallas Aquarium to San Antonio. could you help me with an estimate of the travel distance and time? And then I also have a follow-up question. How about the return trip? And if I know I'm executing the same here, and if you look at it, I'm passing the same thread ID to this graph as well. Okay, and finally, I'm printing uh, the checkpoints, just to show you, how it looks. Okay, and if you look at the stateless module, right? So I'm not passing the config. I don't have the checkpointer resource, when I compile the graph. Okay, so let me run this Python module. As you can see, um, the graph started executing, and then to my first question, it gave me the response, the estimated travel time, travel distance, and the time as well, as you can see. And then to my follow-up question, it did return me the response, right? So it does remember my previous questions, right? Uh, as I said, right? So when you use the checkpointer resource, and then each execution, um, at each and every super step, it saves the checkpoint. Um, in fact, let me show you, right? So I've already printed the checkpoint. So if you use the graph.get state history method, and then if you pass the same config, which is the thread ID, you will see all the checkpoints that are saved for that thread. Okay. So I'm printing the history here, right? So basically, the checkpoint stores the state, and the state is, for at least for in this graph, is the messages. This is my graph state, and then at each and every checkpoint it stores the state, right? So it uses, you see the messages here. So the last one has all the details. So it has my first question. At the same time, it would have my the response, the last response from the I can see here, right? So for the return trip, right? So this is the last execution from the node, right? And then if you look at the first checkpoint, you will see my actual question. Okay. Also, you can see, right? So there is a thread ID in here, right? So by leveraging the checkpointer resource, and then by compiling the graph, by passing the checkpointer resource, we are able to actually make the AI agent remember our previous conversation, right? So let's go to, but in our case, I'm using the messages to store, basically I'm using the messages, and let's go back, right? So if you look at it, right, so I'm using these messages, and then I'm using the add messages reducer, right? So whenever the state gets updated, right? So we keep on appending messages, right? So if the session runs longer, we might um, you know exceed the context window of the LLM, right? So uh, there should be some ways to manage the session, the context size here, right? So there are various ways. You can either trim messages, you can delete messages, you can summarize messages. There are various strategies that you can implement. In this demo, I've not implemented, but you can implement these strategies to trim down your context window sizes. Okay. Um, so as I said, right, so basically to manage this would help, to make sure that you're not exceeding the LLM's context window. Okay. All right. Cool. So if you look at pypy.org, right, so there, I see a lot of SDK is being built for that for the checkpointer resources. I see Cosmos DB, Django, DynamoDB, MongoDB, MySQL, Redis, Snowflake, SQLite, and all that. Okay, so I'm going to show you the Cosmos DB, because when you use the in-memory saver, right? So the in-memory saver would be good if you just use it for some experimentation, running it locally. But it's not going to help you when you actually deploy this AI agent as an API. Okay, when you add more and more users, you need to uh, make it scalable. Okay, so for that purpose, right? So I'm using an external database. I'm going to use the Azure Cosmos DB to save these checkpoints. Okay, so Azure Cosmos DB is a fully managed NoSQL relational and vector database, and it offers single-digit millisecond response times, automatic, automatic and instant scalability, along with guaranteed speed at scale. Okay, so this is one of the offerings from Azure. There are various APIs available from Azure Cosmos DB, and in this demo, I'm going to use the NoSQL API. So this NoSQL API stores data in a document format. Okay, and again, it is highly responsive. Um, you know, and it stores these documents as JSON objects. Okay, so the way Azure Cosmos DB, so this is the resource model for Azure Cosmos DB. So you have the Azure Cosmos DB database account, and then you create a database, and then within a database you can create a container, and then within a container you can create items. Items is basically a collection of your JSON objects. Okay, like those are called documents. Okay, and whenever so there is this concept of partitioning within Azure Cosmos DB. Okay, in order to allow you to scale your containers. Okay, so each the items, right? So the items is in a container. So consider these are like a table within your database, right? So the items is what it's called in the Azure Cosmos DB side of things, right? So the items in a container are divided into distinct subjects called logical partitions. So basically, you can pick um, a field from your data and then mark it as your logical partition. So all of this, but by doing this, right? So basically, it would allow you to scale your Azure Cosmos DB for any number of users. Okay, so in this example, right? So our thread ID fits with the logical partition strategy here. Okay, and within each document, right? So whenever you push anything to the items table, right? So you also need to provide an ID. ID is a required field. So in this, when we use Azure Cosmos DB as a checkpointer resource, it also the Azure like the Langgraph Cosmos DB checkpointer also leverages this ID and make sure that it is unique. So if you look at uh, the code, right? So you see the thread ID and you also see a checkpoint ID from each and every checkpoint. Okay, so this is going to be unique to that particular checkpoint within that thread, right? So in our design, I'll share the link to the docs from the Langgraph Cosmos DB, Langgraph checkpoint Cosmos DB as well. But basically, we can use the thread ID as a logical partition for the container, and then the checkpoint ID becomes the ID for the documents. What's this? So what we are building now, this video is we're going to add Azure Cosmos DB NoSQL API to help with our short-term memory. Okay, so for that we need an Azure Cosmos DB resource. We also need to configure. So more on this, I'll come back to that, right? So basically, I've already I went and created a Cosmos DB resource. Let me show you here. I've created an Azure Cosmos DB account already. And then if you go to the Data Explorer, I have the container created. I'm named it as a memory container here. Okay. I was using it for some testing, so let me create a new container here. Let's call it memory short term memory, and then as you can see from the docs, so you can create the partition key. So let me go back here, let me create that as a partition key and then click OK. All right, so this is going to create a new container. Okay, we call it the short-term memory. So you got the container created, and then items is basically a collection of the documents. Okay, let's go to the code, and let's go to our environment variables. I have the Cosmos endpoint, Cosmos DB key, and then Cosmos DB database as well. Okay, so let me clear this. So I have the Cosmos DB database as a demo, and then let me. So I added the container name here, the short-term memory, to my environmental variables. Okay, I'm going to leverage, use this in my code. So let me close this, and then let's go to this agent stateless, Python module, right? So what I'm doing here is I've installed the Lang Langgraph checkpoint Cosmos DB. So let me open the requirement.txt. As you can see, right, so I've installed the Langgraph checkpoint Cosmos DB SDK, okay, the from PyPy, and then I've imported the Cosmos DB saver class. Also, so I've created this Cosmos DB saver. Um, So by passing the database name and then container name, already provided the short-term memory as a container name in here. Okay, so this becomes my Cosmos DB checkpointer resource, and then I'm passing this checkpointer resource, when I compile the graph. Okay, and at the same time, same as in previous, Python module, right? So I'm passing the thread ID here. I'm passing the input message, the travel, I'd like to travel from this and this, and then have the the follow-up question as well. Um, and finally, I'm printing the checkpoint state. Okay, so let me clear this. Let's run this. Okay, so let me run this. Okay, as you can see, I'm able to successfully run this Python module. So, um, I got the estimated travel distance. At the same time, I also got the return trip details as well. Okay, and you can also see the checkpoints and all that, being created. Okay. Let's go to our right. So as you can see, right, so we have the checkpoints being created within the Azure Cosmos DB um, database here, right? So basically, we are able to use the Azure Cosmos DB as a checkpointer resource, in our example. Okay, let's go back to the code. So what I've also done is I created an API. Okay, so previously I had the API, that would just compile, use the graph, and then provide you a response, right? So I've modified it a bit further. So as you can see, I've imported the Cosmos DB saver class. Okay, um, this is same as in my previous video. I'm using the JWT factory, so to make sure that I dynamically generate and use the OAuth access token when I connect to the MCP server. Okay, I'm passing that to the multi-server MCP client. Okay, basically this is my lifespan function. which I'm going to use when I create the fast API app. Okay, and then from the MCP server, I got the tools, I have the LLM, and then I created this checkpoint resource, by passing the database name and container name from the environment variables. I've, initialized the agent graph. Basically, um, you know, create the this would create the graph for me, compile with the checkpointer resource. Okay, I'm adding it to the app state, the fast API app state. Okay, few other modifications that I've done is I've created the user message schema here. We need a thread ID, since we are using the short-term memory here, and then there is a message. Okay, let me come back to that. So I've created this, fast API app by passing the lifespan function. I have a root endpoint, and then I have a generate thread endpoint. So basically what I'm doing here is, um, you know, I'm parsing the. So if you look at this get user object ID message, right? So basically what it does is it parses the OAuth access token, and then it returns the object ID, so that it makes sure that it is unique. Okay, and whenever the thread ID is created, so it would become the object ID underscore the globally unique ID, generated by the UUID, Python package. Okay, and then I've got another endpoint called agent. So I'm still using the object ID. So I wanted to make sure that the thread ID that's passed um, from the that's sent by the caller matches with their object area, right? So basically, this is to make sure that, for example, a user B, if a user B knows the thread ID of user A, right? I want you to make sure that user B cannot leverage, cannot use their thread ID, right? So I'm looking for the object ID in that thread ID, and only if that object ID matches with the object ID from the access token, right? um, and then only I'm generating the response, right? So basically, this call agent function here takes the user message and the thread ID as well, right? And then it passes that, when it invokes the graph. Okay, so this is what the API does. Um, what I did was I also packaged this into a Docker image. I built this Docker image, and I'm calling it as an AI agent, API memory. Okay, I push this Docker image into my, Azure Container Registry. I have the, if you go to my repositories here, you see the AI agent API memory. So this is my new Docker image. Okay, and if you go to the app service for the where the agent API runs, um, so I've already added some environmental variables. So if you look at it, right, so I have as the Cosmos DB container name as a short-term memory, and then I have the Cosmos DB endpoint key. This is just for the demo. You can also use role-based access controls to connect to the Cosmos DB here. Okay, let me go to the my deployment center here. Um, Let me copy the image name, and then let me paste it here. Let's save it. So basically, I'm deploying it manually. Again, just for the demo here. Let me go to the overview page. So now, you know, it's running the AI agent API memory. Okay. All right. So basically, what we have done now is, let's go to our diagram here. So we've, we're able to create the Azure Cosmos DB. We have updated our API logic with the Azure Cosmos DB as a checkpointer resource. Okay, and then we have updated the environmental variables in the Azure App Service to connect to that Azure Cosmos DB. Okay, as I said, right, so we already configured the checkpointer resource for the Langgraph agent. Okay, So this is now running. Let's go to our Postman and test it. So let me open the um, two requests here. One is for the generate thread, right? So this is where our API is running, the Azure App Service, and this is the generate thread endpoint. Okay. Let's generate the auth access token here again. I've already configured um, all of the details here. So let me generate an access token. I got the access token. Let me use that token. Okay. First thing first, right? So we need to generate the thread ID. So let me run send a request, right? So I got the thread ID. So for just confirmation, right? So um, let's copy the access token from here. Okay, and let's go to jw2.ms. Let's copy this access token. Okay, as you can see, right? So there is an object ID. So this is my user object ID in the tenant. And then if you go to um, the Postman, right? So you see this object ID, which is A6E18168, right? A6. So basically, the prefix of the thread ID is the object ID, and then this is the globally unique ID. Okay. So let me copy this thread ID, and then when I interact with the agent, I need to copy the thread ID here, and let's ask the same question, right? So I'd like to travel from Dallas Aquarium to San Antonio SeaWorld. Let me know how long it takes with the current traffic conditions. Okay, I'll just make sure that I use the access token. Okay, and then let me run this. Okay, so the since I'm passing the object ID, the thread ID, and then I'm using the access token that has the object ID, right? So it's able to validate and then give me a response here, right? So it says 4 hours and 18 minutes, right? So let's ask a follow-up question, right? Uh, what about the return trip, right? So let's send the request again, right? So, you know, it's able to remember my previous question, right? So it says the current travel time by car from SeaWorld San Antonio back to Dallas World Aquarium, considering current traffic conditions, is approximately 4 hours and 10 minutes, right? Let's ask another question, right? Uh, what was my original question, right? Um, right, so as you can see, right, so it's able to um, give me my first question that I've asked, right? So basically, we have added we have made this API stateful by using this, by using the checkpointer resource, which is our Azure Cosmos DB, right? But as I said, right, so thread ID is unique, right? And then you need to pass this thread ID to make sure that it uses the previous conversations. Okay, let's go back to code again, right? So basically, what you've done is we have built an API, the AI agent running as an API, right? We added state by you know adding the Azure Cosmos DB as a checkpointer resource. All right. Thanks for watching.